High-performance computing is essential in scientific discovery, but it has become increasingly complex and expensive. Because HPC systems are under high demand and simulations have lengthy runtimes, every run must count, making effective performance analysis crucial to an application's success. Only with regular, comprehensive performance profiling can the simulation developer learn how well or how poorly the application is running, discover opportunities for optimization, and ensure efficient subsequent runs.
Most traditional HPC performance analysis tools are used only occasionally and for individual application runs. These tools generally maintain only limited and specialized contextual information. They have inconsistent manually added metadata, and they tend toward specific types of analyses. Instead, our HPC application developers need embedded performance tools that are easily used on every run and support analyses for many runs across a variety of hardware architectures and input configurations. These tools should capture broad contextual information, they should provide consistent metadata, and they should deliver multiple types of analyses.
The bar is high, which is why our team at Lawrence Livermore National Laboratory has developed Caliper and Thicket, which together provide comprehensive performance measurement and analysis.
Caliper and Thicket are complementary software libraries that give developers the power to add lightweight performance annotations directly into their source code and activate these measurements at runtime. With the resulting performance profiles, developers can explore the breadth and depth of the data, as well as compare multiple runs over time on different HPC systems and at scale.
An HPC application is like an elite athlete who must consistently perform at a high level and who gets better as their training regimen improves. Caliper and Thicket provide the coaching necessary for HPC performance optimization. First, the coach records stats such as distance, height, speed, and other measurements that factor into performance, and then together, the coach and elite athlete analyze the results over time to help the athlete train smarter and perform better.
As the HPC application runs again and again, and across different types of hardware, Caliper collects a detailed profile each time. Then, Thicket aggregates and synthesizes the performance for multidimensional analysis and exploration.
Similar to how the athlete may need to perform well in different environments, the HPC application may need to run on different computing architectures. Because Caliper's annotations and metadata are embedded into the source code, performance metrics are tracked whenever and wherever the application runs, enabling Thicket's exploratory data analysis of the data on demand. Caliper and Thicket are designed for the complexities of parallel and distributed computing, where any one aspect of an application run can go wrong, or multiple problems can surface in combination. Caliper's annotation features mark the high-level logical regions within the application's source code, such as phases, kernels, communication, and input-output operations.
Metadata about the run is recorded automatically, including which user invoked it, the date, time, and system where it was invoked, the executable name, and the number of parallel processes used. Performance profiles can be collected routinely to support long-term automated profiling in workflows.
For exploratory analysis and cross-run comparisons, Thicket provides visualizations as well as the ability to filter and sort run contexts, metadata, and trends. Users can drill down into a specific profile as well as compare performance across thousands of profiles.
Most of these features are customizable. Users can record metadata specific to their applications, for example, the simulation's input configuration. And at runtime, users can determine which performance metrics they want to track and at what frequency.
End-to-end, Caliper and Thicket provide performance insights gleaned from meticulous tracking, ultimately empowering our users in the quest for application optimization and reducing the overhead of piecemeal or occasional performance profiling.
One of Lawrence Livermore's elite application codes is Marble, which simulates high-energy density physics, high explosives, and magnetic and laser-based energy sources. Marble runs on a range of HPC machines, including the exascale El Capitan system. This large-scale multiphysics code plays an important role in the lab's national security mission, so it must perform at the top of its game.
Marble needs to run on all of our latest and greatest computers, and it also needs to run on our commodity computers. As you run on more and more resources, it's important to understand if you're getting the same performance as you scale up to more nodes. Caliper allows us to annotate the regions of our code as we're developing them to better understand what's actually going on using tags that are meaningful to the developer. Thicket allows us to take ensembles of simulations and understand the performance of them and visually demonstrate that. Caliper and Thicket make it easy for the developers to run analyses on their own on a daily basis. And that's what we do on Marble. As we modify a function in the code, we want to understand what the performance was beforehand and what the performance is afterwards. So it helps us visually see right away that, yes, the performance is 20% better on this important function. With Caliper and Thicket, it turns performance analysis from something that happens once or twice a year into something that happens on a daily basis.
Optimal HPC performance sets a high bar for application teams. They can meet the demands of scientific computing with Caliper and Thicket, which are open source and available on GitHub.